Hello, I'm Alan, and in Harvard, I'm a PhD student in mathematics. My project is called a Julia set generator. And what it is a tool that allows researchers and enthusiasts generate Julia sets quickly and in a way that they can get qualitative data out of it. So what are Julia sets? Well, in the field of complex dynamics, one is often interested in the behavior of orbits of complex valued functions. And just for simplicity, we can assume that our function is a map from the complex numbers to itself. And the orbit of some starting point z sub 0 is simply the sequence z sub 0, f of z sub 0, f of z sub 0, and so on. So we repeatedly apply f to our initial value. The filled-in Julia set is the set of complex numbers whose orbit remains bounded. So this is a subset of the complex plane that people would be interested in. And the Julia set is exactly the boundary of the filled-in Julia set. So for some examples, this is the Julia set of the function z squared minus 1. It's often called the basilica Julia set because it looks like a church, basilica church. And as you can see, there's some nice self-similarity properties to this. It's a fractal-like structure. This is another example. It is different from the previous one in which it doesn't have distinguished blobs. And here is just an array of examples, which I've taken from Randall Pike's website, from Simon Fraser University. And as you can see, there's a rich collection of examples of Julia sets. And I wanted to create a tool that allows one to quickly arrive at these examples. So here is the actual project I made. I have two canvases. The canvas on the right is called the Mandelbrot set, and as you can see, there's a yellow dot on here. And on the left is going to be the corresponding Julia set to the yellow dot. And so the yellow dot corresponds to the value of c. And this tool is only going to show the Julia set for z squared minus c, or z squared plus c. And so how it works is you can move this yellow dot around, and dynamically the Julia set on the left will change. And so you can get very interesting behavior. And so, for example, interesting behavior appears on the boundary of the Mandelbrot set. And once we get our desired Julia set, we can also explore it further. So I can move it around with the arrow keys or WASD. I can zoom in just by clicking or pressing Z. I can zoom out by pressing X. I can also zoom out by clicking after switching out the zoom in mode. Zoom in again, and then here I can move around, and I can reset the original scale with R. Yeah, and that's my project.